In problem number 7, we are going to have to change both of our equations to get the same coefficient for x. We have the coefficients of 4 and 3, so we're going to have to multiply our first equation by 3, which will give us 12x plus 15y equals negative 21. And we will multiply our second equation by 4, which will give us 12x plus 8y equals negative 56. This gives us 12 for both of our coefficients of x. Because they have the same sign, both being positive, we are going to have to use subtraction to eliminate our x term. And then we will have to subtract each of our terms. So 12x minus 12x will give us 0. 15y minus 8y will give us 7y. And negative 21 minus negative 56 is equal to 35. If we divide each side by 7, we see that our y value is equal to 5. As in previous examples, to find the corresponding x value, we will substitute in our y value of 5 into one of the original equations. I will use the first equation, 4x plus 5 times 5 is equal to negative 7. And simplifying, we get 4x plus 25 is equal to negative 7. When we subtract 25 from both sides, we get 4x equals negative 32. And then dividing both sides by 4, we see x equals negative 8. So our x value is negative 8. Our y value is 5. As an ordered pair, we would write that negative 8, comma 5. To get the same coefficients for x, I am going to multiply the first equation by negative 3, and that will give us negative 15x minus 9y equals 36. The second equation I am going to multiply by 5, and that will give us negative 15x plus 35y is equal to 80. Because the signs are the same for my coefficients of x, I am going to have to use subtraction to eliminate my x values. And that means that I will be subtracting all of my like terms. So again, I like to box out my sets of like terms to help us see our individual problems. Negative 15x minus negative 15x will be 0, which will cancel out. Negative 9y minus 35y is negative 44y. And 36 minus 80 is negative 44. So we can divide each side by negative 44. And that tells us that our y value is equal to 1. To find the corresponding x value, as in the previous problems, we will substitute this y value in. I will use the first equation, 5x plus 3 times 1 equals negative 12. Simplifying, we get 5x plus 3 equals negative 12. When we subtract 3 from both sides, we get 5x equals negative 15. And dividing both sides by 5, we see our x value is negative 3. So for problem number 8, our x value is negative 3. Our y value is 1, and we can write that as an ordered pair, -3, 1.